Now in the second question, we have a graph plotted with this equation over here, and then we are given a point P on this graph, and we are told that it has an x coordinate of 2. So the x value of this point is 2, and in the first question I need to find the y coordinate for it. To do so, I'll just put in the y coordinate, x coordinate that we know in here. So replace the x with 2 and find the y value. If I do it, I get 2 to the power 2 minus 4 times 2 times y plus y square equals to 13. I get 4 minus 8y plus y square. I'll move the 13 over here, subtract 13 of both sides. So we get y square minus 8y minus 9 equal to 0. Now we can factorize this. We get y square minus 9y plus y minus 9 equal to 0. So y times y minus 9 plus 1y minus 9 equal to 0. So y minus 9 times y plus 1 is equal to 0. Either y is equal to 9 or y is equal to minus 1. Now in this question, we are also given the information that y is greater than or equal to 0. So we can ignore this one. So y would be 9. That's the answer. So we get the y value of P, which is 9. Now we need to find dy dx in terms of x and y. Since we have y and y square over here, we'll carry out implicit differentiation. Now if I differentiate 2 to the power x, we'll go term by term. If we differentiate 2 to the power x, we get 2 to the power x times ln 2. Now for the next term, if we differentiate 4 times xy, we can use the product rule over here. So 4 times 4x times y. This is u, this is v. Du by dx is equal to 4, whereas dv by dx is just equal to dy by dx. If you differentiate y with respect to x, you get dy by dx. And if you differentiate 4x with respect to x, you get 4. Now the product rule says that dy by dx would be equal to v du by dx plus u dv by dx. So v over here is y times du by dx is y times 4, u dv by dx is 4x multiplied by dv by dx, which is just dy by dx. So this is the differentiation of the second term. We have a minus in front, so we'll just add it. So minus 4y minus 4x dy by dx. Now for the third term, I have to differentiate y square, and to do that I need to use the chain rule. So y square, if I want to find ddx of y square, I can use the chain rule. So I can assume u, I'll let u be y. So du by dx would be equal to dy by dx, because when we differentiate y with respect to x, we just get dy by dx. Now the original expression is y square or u square. Y square is also u square. So d times du of u square would be 2u. Now using the chain rule, we multiply this and this to get the final answer for t dx of y square. This will just be 2u times dy by dx, and we know that u is y, so this is 2y dy by dx. So in this expression we add plus 2y dy by dx, and finally if I differentiate 13 with respect to x, we just get 0. Now we need to make dy by dx the subject, so I move everything that doesn't have dy by dx to the right. So on the left we have 2y dy by dx minus 4x dy by dx, and we move everything else over to the right. So on the right we have 4y minus 2 to the power x ln 2. Now I can take dy by dx common on the left. I get 2y minus 4x equal to 4y minus 2 to the power x ln 2. And finally I can divide both sides with 2y minus 4x. So I get dy by dx equal to 4y minus 2 to the power x ln 2 divided by 2y minus 4x. And that's the answer for part B. Now moving on to part C. We have the tangent to C at point P, which crosses the x-axis at point Q. We have to find the x-coordinate of Q over here. Now at P, x is equal to 2. So the gradient of the tangent will be the value we get if we put x equals to 2 and y equals to 9, since we calculated this in part A. So if I input this value for the expression for dy by dx, I'll get the gradient. So I'll do that over here. I already know what dy by dx looks like. So dy by dx is equal to 4y, 4 times 9 minus 2 to the power x ln 2, so 2 square ln 2 divided by 2y, so 2 to the power 2 times 9 minus 4 times 2. So the gradient at this point will be 36 minus 4 ln 2 divided by 2 into 9 minus 8, so 10. And I'll leave this because I want to find the value in the absolute form as we are given in this question. Now that's just the gradient of the tangent. We need to find the equation of the tangent as well, and we know it passes through P. So P is 2, 9. So the equation of the tangent can be found using y minus y1 equals to mx minus x1. So y minus 9, we'll use 2 as x1 and 9 as y1. So y minus 9 is equal to 36 minus 4 ln 2 divided by 10 times x minus 2. So y, I'll not simplify this further. Now I just need to find the x value when this passes through the x-axis. Now at the x-axis, the y value is 0. So 0 minus 9 is equal to this expression on the right. I can divide this expression on either side, and I can get x minus 2 equal to minus 9 divided by 36 minus 4 ln 2 by 10 So x would be minus 9 divided by 36 minus 4 ln 2 by 10 plus 2. But we are not done simplifying this yet. I can write this as, I can move the 10 to the top. I'll get minus 90 divided by 36 minus 4 ln 2 plus 2. But if I look over here, I want it in this form, which I don't have yet. I want ln 2 on the numerator and the denominator. And there's nothing outside the fraction. But here we have the plus 2. So I'll just move it here. So I get minus 90 here. Now if I want to change the denominator of 2, I need to multiply 36 minus 4 ln 2 to it and then divide it with this. So on the top we get 2 times 36 minus 4 ln 2. The x value would be minus 90 plus 72 minus 8 ln 2 divided by 36 minus 4 ln 2. Hence the x value would be minus 8 ln 2 minus 18 divided by minus 4 ln 2 plus 36. And this is the answer. It's exactly in the form that the question wants from us.